Okay, so this is how it looks like when you draw a graph for the property specification. That's again the example with the book. So a book has a title. That was one of the properties, book, title, and then we have a literal with the title of the book. So title itself is a property. So this is the first part that we've seen. You say RDF type, RDFS property. Property, by the way, is another RDFS class. And then we have to say for a title what goes in the domain and range. So here we define that the domain of a title is any work of type fiction, which again is of type class, and the range is an RDFS literal. So here we have a string literal for the actual book title with a possible language tag. And again, RDFS literal is of type RDFS class. When you serialize this, it looks like this. So let's start with turtle because this is what you're used to. We have title, and then we have these three pieces of information that we defined. We say that title is a property, we have the domain, and then we have the range. So in general, these are the three essential things you need for a title, for a property. You have to first define that it is a property, then you have to define the domain and the range. In the lab, you should have also seen RDF XML. Most likely you're not going to work that much with RDF XML, but it appears in a couple of places. So yeah, you know, you can convert it into a different representation like turtle or n triples, and you should know a bit how it looks like. Most likely you're not going to have to work directly with RDF XML. So we have seen classes and subclasses, and what you can do in RDF as well is define a subproperty for a property. Again, if you think of programming, that's probably going to be a bit confusing because I don't know of any standard programming language where you can have a subproperty, but in RDF, that's possible to define. So when you have a property, you can say that it is a subproperty of another property. And just like subclass of, you do it with RDFS, and in this case, subproperty of. So similar to class instances, you say that all the resources related by one property are also related by the other property. For example, you can have a property is parent of, and then a subproperty is father of the property is parent of. Now, when you are father, you're always a parent, but not the other way around. So we've covered the most important constructs in RDFS. There are a couple of more. I'll show you two more that you'll see in practice, which are basically helper constructs for enriching your graphs. And these are RDFS see also and RDFS is defined by. See also is basically just to store a link to another resource. And this other link can be in any format. So you can, for example, have something in your knowledge graph, a URI, and then say see also and refer to anything else. And this here doesn't have to be an RDF node. This can be anything. It can be an HTML page. It could be a movie, whatever you want. So basically, you can link some additional resource to your graph. Then there is an is defined by, and this you can use to refer to a vocabulary that defines the subject URI. We'll see, I think we'll have an example for this a bit later on. Additionally, there are a couple of data structures. So there are things like bags and lists and so on. I'm not going to show them here. When you actually need them in practice, you should read up a bit more on how they work. But I don't want to introduce more stuff that you don't need right away. So just be aware that there are data structures like lists for RDF. And when you have to use them, look at some of the references that I'm going to give you later. So this table summarizes all the constructs that we've covered, the important ones at least. So we talked about classes, how to define a class, how to define a property, how to define instances, subclasses and subproperties, and for a property, the domain and the range. So much for the technical bit. And in the next part, we're going to talk about some existing vocabularies and how to use them. See you then.